All right, today we are going to take notes on motion graphs. The first thing I want you to look at is these two little graphs that I drew. Do these graphs, there's no points on the graph, I didn't label them, but you can pretend. This axis says time, so we can pretend it's 1 through 10. This axis says distance, so we can say this is 1 through 10 seconds. This is 0 through 50 meters for both graphs. Do these graphs show the same thing? I want you to really answer that in your head. Do these graphs show the same thing happening? So they both have a horizontal line, but they do not show the same thing at all. This graph is a distance time graph. So what it's saying is as time is passing, the distance isn't changing. So if we pretend this was a distance of 30 meters, let's say this was a person standing. This person was at 30 meters at 0 seconds, at 1 second, at 2 seconds, at 3 seconds, at 4 seconds, at 5 seconds. They never changed from 30 meters. So that means they're just standing there. They're not moving. So this graph shows no motion. And y'all are not drawing this. I'm just showing you something. Whereas this graph is a speed time graph. So if this is a speed of 30, then that means that this person is going 30, let's say, meters per second at 0 seconds, at 1 second, at 2 seconds, at 3 seconds, at 4 seconds, at 5 seconds. So this graph shows constant speed. That means the speed is not changing. So this graph is someone traveling at 30 meters per second the entire time. This graph is no motion. But they looked the same. They are both horizontal lines. This is why you have to read the axes first. The first thing you need to do is read what is on your axis. This one is distance time. This one is speed time, and it makes such a difference. You haven't taken any notes on these graphs, but just by looking at them and reading the axis, you could have figured out what was going on here. You could say the distance is not changing even though time is passing. So you're standing still. You could look at this and say the speed stays the same the entire time. So you're going at constant speed. This is like when I get in a school zone. When I get in a school zone, I want to go as fast as I can without speeding, but I definitely don't want to go under the speed limit. So if I get in that school zone and the speed limit is 30, I'm going to stay exactly at 30 the entire time. I don't want to speed because they give you big tickets in school zones, but I don't want to go anything less than 30 because it's so slow and I'm trying to hurry up. So constant speed, not changing. All right, I wanted to point that out before we start our notes because in order to be successful, you have to always read the axis because we're going to look at two different types of graphs. All right, we are going to title these notes. This should be page 13. And we're going to title it Motion Graphs. And let me show you. We are going to take up the entire page. This is what your notes will look like. So we will take up the whole page. So don't write too big or else you might need to go on the next page. That's okay. I'd rather you go into the next page than not have the notes. So, anyways, and we're going to draw graphs. And I'm not going to use a ruler, so you don't need to use a ruler. It's okay if your lines are not perfectly straight. The first type of graph we're going to draw is going to be a distance time graph. And I'm going to use a lot of colors just to make things stand out. But if I was you, I would also use colors on some of this, but I would use pencil when you draw the graph in case you make a mistake. All right, so my first graph, see, it's not a perfectly straight line, but it's not bad. My first graph is going to look like this. And it's going to be a distance time graph. I'm going to label as best I can on here. 1 second, 2 second, 3 second, 4 second, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you might want to do that in pencil in case you mess it up. I got lucky. I didn't mess that up. I'm going to do 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. So 10, 20, 30, 40, 50. And I'm going to label that this axis is time in seconds. And this axis is distance in meters. So if I was you, I would pause it and set your graph up and make sure that you have it correct. So use a pencil erase if you mess up. But I'm going to move on. So we're going to kind of plot some points on this graph. I think you'll have plotted points in math, so this should be relatively familiar. We're going to start at 0, 0. My next point is going to be at 1 second and 30 meters. So 1, 3, 1 second, 30 meters. And then let me zoom in for y'all for now. Sorry, this is hard. Let's focus. Okay, maybe that's a little better. It's a little bigger for y'all. All right, the next one's going to be, I'm going to go to 4 seconds and 10 meters. And I'm just estimating. This is about 4, about 10. And I'm going to go 6 seconds, 10 meters. And then I'm going to go last one, 10 seconds, 50 meters. So this is point A, B, C, D, E. And now I'm going to connect the points as best as I can. Oh my goodness, that was so bad. That was supposed to come out better. Okay, well, it's all right. It's okay. All right. So let's analyze this graph. When we are going from point A to B, how far do we travel? Well, we start at 0, we travel to 30, so we travel 30 meters. How long does it take us? 1 second. So we travel 30 meters in 1 second. Let's skip a few lines. Let me zoom back out. And let's skip a few lines, like 3. 1, 2, 3. And let's calculate speed. Remember, our formula for speed is distance divided by time. So if we know the distance that we went from point A to B, and we know how long it took us we can calculate the speed. So we want the speed from point A to point B. How fast we traveled when we went from A to B. So what did we say our distance was? We started at 0, we went to 30. So our distance is 30 meters divided by 1 second, means our speed is 30 meters per second. Let's figure out B to C. So point B, this is where y'all are going to get tricked. How far do we travel when we are going from point B to point C? We start at 30 meters, we go to 10 meters. So we're changing 20 meters, 30 minus 10, but we're traveling back. So the first second we traveled away. We moved away from the start. We went from 0 meters to 30 meters. But then we travel back towards the start, because we go from 30 meters to 10 meters. That is a change of 20 meters, 30 minus 10, but we're traveling back to the start. So when we're calculating speed, our distance is 20 meters because that's how much we changed. How long did it take us? We started at 1 second, we went till 4 seconds. So 1, 2, 3. 4 minus 1 is 3 seconds. It took us 3 seconds. You're going to get this wrong if you say it took us 4 seconds, because point B started at 1 second. We went from B to C, which was at 4 seconds. So the change in time is 3 seconds. If we divide, that'll give us about 6.67 meters per second. So where were we traveling at a faster speed? Was it from A to B or B to C? We can answer that for sure because we calculated speed right here. So let's keep going. Let's see where we have the greatest speed in the whole graph. Let's go from point C to point D. So at point C, we are at 10 meters. At point D, we're still at 10 meters. So how much did our distance change? It didn't change. So our distance is 0. We had no change in distance. We started at 10, we ended at 10. How much time passed? It started at 4, it ended at 6. So 2 seconds passed. 0 divided by 2 is still 0 meters. So if our distance didn't change, that means we weren't moving. We were stopped. Standing still. We weren't moving then. Okay, last one. Let's go from point D to point E. So at point D, we were at 10 meters. At point E, we were at 50 meters. So overall, we went from 10 to 50. That is a change of 40 meters. So our distance is 40 meters. We started at 6 seconds. We ended at 10 seconds. So our time is 4 seconds past. 1, 2, 3, 4. 4 seconds. That's the change in time. So 40 divided by 4 is 10 meters per second. And in this one, we started at 10 meters, we moved to 50 meters. So again, we were traveling away from the start. So a distance time graph can kind of be like a path of where you walked. You started, so let's pretend like it could be a car, it could be a plane, but let's pretend this is a graphing where we walked. And let's pretend we were on a football field. So we started at the 0-yard line. And in 1 second, we ran 30 meters. I guess we started at the 0 meter line. And in 1 second, we ran 30 meters away from the end zone. Then for the next 3 seconds, we turned around and we ran back towards the end zone 20 meters, all the way to the 10 meter line. And then we just stood there for 2 seconds. We stood there and we didn't move. We stayed on the 10. And then we decided to run away from the end zone again. And we ran 40 meters away. But it took us 4 seconds this time to run 40 meters away. I can read it like this because it's a distance time graph. It's showing us how far we traveled in an amount of time. So 2 important things on this graph is we need to know that from point C to point D, there's no change in distance. That's why we put stop there, because we didn't change distance. We stayed at 10 meters. So we're stopped. Where do we have the greatest speed on this graph? Is it when we run away? Is it when we run back towards the end zone? Or is it when we run away again? Where are we going the fastest? Where do we have the fastest speed? You don't have to guess. You don't have to guess by looking at the graph. You have your answer down here. You calculated it. 0, 10, 6.67, 30. We have the fastest speed from point A to point B. This is the greatest speed. So that's a distance time graph. Now let's look at another type of graph. Let's look at a speed time graph. And remember what I showed you at the beginning. These are going to be different because it's a different type of graph. So you really have to read what your axis is telling you. We're going to draw 3 different graphs. So I'm just kind of letting you know where our 3 graphs are going to be so you can space it accordingly. All right, so for each one, let's go ahead and label the axis. These are all speed time graphs. So all 3 of these are going to be speed time graphs. The first one, we're just going to make it a straight line. So let's think. We said this already when I was showing you that picture earlier. What is happening here? Is the speed changing over time? No, it's not changing. We're staying at that same speed. We didn't label the axis, but we don't have to. Whatever speed that it's at, it's staying at that same speed. So we are traveling at a constant speed. So what you need to know is this graph showing acceleration? Is there any acceleration? Well, think about 2 days ago. What are the 3 forms of acceleration? Acceleration is speed up, slow down, change direction. Are we accelerating? We're traveling at a constant speed. So did we speed up? We never changed speed. Did we slow down? We never changed speed. Did we change directions? No, because we would have had to change speed to do that. So let's put no acceleration. No acceleration. All right, let's look at the next one. For this one, we're going to start here and we're going to go down. So let's think about what's happening in this graph. In the beginning, what was our speed? Was it faster? Was it high or was it low? In the beginning, our speed was high. Towards the end, it got lower, lower, lower until we were at a low speed. So what happened to our speed? It decreased. So we're going to put decrease speed. So if we decrease speed, are we accelerating? Did we speed up? No. Did we slow down? Yes. So if we slow down, we are accelerating. So this graph does show acceleration. All right, last one. We're going to make this graph look like this. So what's happening here? What's our speed like in the beginning? It's pretty low. What happens as time passes? Speed increases. So let's put increase speed. All right, so are we accelerating? Did we speed up? Yes, we sped up, we increased speed. So we are accelerating. So on a speed time graph, you can decide if it shows acceleration based on if you speed up, slow down, change directions. If this line is horizontal like this, you're traveling at a constant speed. That speed is not changing. What if this graph showed a horizontal line down here at the 0? Well, then your speed would be 0 for the whole time, so you're not moving. But since the speed is way up here, we know that it is changing speed, or it is going a certain speed. It's not changing, it's staying at that speed, but it is moving. Okay, let's look at our top graph again. Does this top graph show acceleration? Well, what are our forms of acceleration? Speed up, slow down, change directions. So we calculated speed for each part of this graph. Is the speed changing? Yeah, in the beginning, we're going 30 meters per second. Then what? Then we changed to 6.67 meters per second. So is that acceleration? 30 to 6.67? Yeah, we slowed down. Also, did we change directions? We were moving away, now we're moving back. So we changed directions. Right here, are we accelerating? We're stopped, we're not moving. So are we speeding up? No. Are we slowing down? No. Are we changing directions? No. But then we begin moving again at a speed of 10 meters per second. So now we are accelerating. We accelerate at the point because we go from stop to moving. But this whole time you're traveling at a constant speed of 10 meters per second. I know this is a constant speed because it's a straight line. So think of math. Let me show you something. If the line is like this, you're moving at a constant speed because it's a straight line. If the line is like this, if it's curved, it's not constant. This would be speeding up. That would be acceleration. You're increasing speed. This is a constant speed because it's a straight line. So a constant slope. This is not a constant slope if you're thinking of math. There's one more thing we need to talk about. You could be given a whole graph and asked, what is the average speed? So we said this is a graph of us running on a football field, right? So what is the average speed of the runner during that time? So that means we want the average speed of the runner over the whole graph. If you were asked to calculate average speed, let's make this little special thing over here because this is important. If you were asked to calculate average speed, we always use the last point on the graph. So if they want the average speed of the whole graph, we use the last point on the graph to calculate that. So if we look at our graph, the distance on the last point is 50 meters. So our distance is 50. The time is 10 seconds. So our time is 10. So the average speed is 5 meters per second. So we can calculate the speed of one section on the graph between 2 points, or we can calculate the speed of the whole graph, the average speed. So this is kind of interesting because at one point in time, we traveled at 30 meters, then at 6.67, then 0, then 10. But that makes our overall average 5 meters per second. It's kind of like you might make a 70 on an assignment, a 100 on an assignment, a 0 on an assignment, a 60 on an assignment, but your average is a 75. So these are the speeds that made up the different sections of the graph. This is the overall speed, the average speed. All right, so big takeaways is always check what type of graph you're looking at, whether it is a distance time graph or a speed time graph. And then read what's happening on the axis each time to know what's going on in the graph. You are going to do a card sort next. Make sure you look first. Is it a distance time graph or a speed time graph? Then look at the graph and ask yourself, is the speed increasing or decreasing? Or if it's a distance time graph, what is happening over time? Am I moving away? Am I standing still? So good job, y'all. And this was this will be page 13 in my notebook.